Okay, so let's start our session. Let me start sharing my screen. Okay, so basically, yesterday we went through the various vibes in terms of understanding statistics, where we tried to understand what is statistical analysis. Uh, Give me a second. So we were trying to talk yesterday about statistics. What is statistics? Statistical analysis. Then we went ahead, understood about various terms which are involved in statistics, and then we got the gist of few things, which is the various measures which we have: the measure of central tendency, the measure of uh, dispersion, and then we happen to use the things such as probability. So within probability we understood what is basic probability, how do we calculate probability. Now, in continuation to the same thing, one of the important key takeaway of probability from a data science and a machine learning standpoint is the Bayes theorem. So Bayes theorem was a theorem which Thomas Bayes first basically showed us how the new evidence to update the belief. So basically the statement seems to be very relevant, right? So he showed how to use the new evidence to update the belief. So what we will do is basically the Bayes theorem. We have a formula, the mathematical formula as derived by Thomas Bayes. We have that, but let's try to understand the way the Bayes theorem works, and then we will come back to the theoretical definition of this. That way it becomes relatively simpler, easier for us to understand and get going. So let's see this particular thing. Now let's take a scenario where we have two dice. You know, now basically a dice is something which has six faces: one, two, three, four, five, and six faces, and each of the dice Of the two dice, one dice is a fair dice. What do we mean by a fair dice? Basically, a dice which is on unrolling it, there is a equal probability of any number getting shown. That is a fair dice. Let's assume for a minute. Let's assume for a minute there is an unfair dice. So what is this unfair dice? It's a unfair dice is a dice where 50% of the time the number 6 we will get every time on rolling. The chances of getting number 6 is 50%, and chances of getting any other number between 1 to 5 is 50%. So that is the unfair dice. Now what is that we will have to see is, if we have to pick one of the dice between the two, if we have to pick one of the dice between the two and we have to roll it, what is the probability of getting 6 is one thing what we have to see. Let's see how this works pictorially, then we will see mathematically how it works. Assume these are my two dice. One is biased, one is unbiased. Okay, the left side we have the biased, the right side we have unbiased. Now, if at all you happen to see, in a biased dice, what we have seen, we said 50% of the times there is a probability of number 6, and the remaining 50% of the times there is a probability of 1, 2, 3, 4 and 5. Therefore, what I have done, in the biased dice, I have given the various options 1, 2, 3, 4, 5. The remaining 50% of the times I get number 6. While in the unbiased or a fair dice, I have an equal probability of 1, 2, 3, 4, 5, 6. So which means in this case, if I happen to see there are 10 options, 10% each, which I get adding to the 100%. In this case, I get 1, 2, 3, 4, 5, 6. Now, what we will do is, since we have to compare both of them, let's try to multiply this to get the common values. I will multiply the number of biased side. We already have 6 into 5. Therefore, I get 30. Here there are 10. Sorry, there are 6. I will multiply into 10. It becomes 60. So now the number of options on your unbiased is also 60, on your biased is also 60. So now what we did is, basically we got a level playing ground to compare both of them. Now with this particular thing, our scenario is, on rolling a dice we should get number 6. So if you see this, I will take away all the things which are related to 1, 2, 3, 4 and 5. So I will take away this 1, 2, 3, 4, 5. And here also in the unbiased side also, I will take away 1, 2, 3, 4 and 5. Now, if you happen to see, we have taken away, I have striked out the options 1, 2, 3, 4 and 5. I have striked away the options 1, 2, 3, 4 and 5 on my biased and unbiased. Now, if you happen to see this particular thing, if we go ahead and see the formula of getting the probability, what is that we need? We need probability of picking a biased dice and on rolling getting 6 is the probability what we are checking. Therefore, probability of biased and getting 6 will become 30 by 30 plus 10, because here if you count 1, 2, 3, 4, 5, 6, therefore 6 into 5 times, which is 30, 6 5s are 30. Therefore, in denominator from the biased side, you have 30. From the unbiased side, you have 10, which are the total number of options where you will get 6. Therefore, 30 plus 10. In the biased side, you have option only 30. Therefore, 30 divided by 30 plus 10, which becomes 30 divided by 40, or 3 by 4, which means my probability of picking up a biased dice and on rolling getting 6 is 3 by 4. That is my probability. Now, if I happen to choose, come back here and see the scenario. The same theoretically, if you happen to prove this, let me see this particular thing. So I have a fair or a unbiased dice, unfair, which is 50% time number 6. Now the scenario is I have to choose one die between the two, and on rolling I have to get number 6, which means A is equal to choosing a biased die, B is equal to rolling and getting 6, A and B. Now, let me go ahead and see probability of A or A of B, which is the Bayes theorem formula. Let's go ahead and derive each one of them. Now, P of A of B becomes probability of choosing a biased dice and getting 6. That's what we get here. Then P of B of A. What is P of B of A? Probability of B, which is 6, and getting biased. Therefore, here A is choosing the biased die, B is rolling to get number 6. Therefore, 6 of biased. Therefore, in the biased section, we said a 50% chance of getting 6, which means 1 by 2. This is P of B of A. What is P of A? Choosing a biased die. How many dice are there? 2 dice are there. Therefore, P of biased is equal to 1 by 2. Therefore, we got P of A of B, P of B of A, P of A, which is all these three things. Now, we have to get probability of B. What is B? Rolling the dice, getting 6. Now, let's see how exactly we get P of B. P of B means P of 6. We have to get the probability of getting 6. Now, if you happen to see this, probability of 6 can happen in both biased and unbiased. Now, in the biased section or in the biased dice, we have a 50% probability, therefore 1 by 2. In a unbiased or a fair dice, we have probability of getting 6 as 1 by 6. Therefore, I have 1 by 2 and 1 by 6. What I do is I multiply both the sides with 1 by 2, add both of them, because I can get biased from the I can get number 6 from the biased dice or from the unbiased side. Therefore, I get this. Now, if I add the values, I get 4 by 12. 3 by 12 plus 1 by 12, which becomes my 4 by 12. If I reduce it, I get 1 by 3. Therefore, I get probability of B is equal to 1 by 3. So now in this formula of Bayes theorem, I got all the four values: P of A of B, P of B of A, P of A, P of B. That way, I go ahead this way, which we happen to see here. When I substitute all of this in my formula, I get probability of biased and getting 6 is equal to P of B of A, which is 1 by 2, P of A, which is 1 by 2, divided by P of B, which is 1 by 3. Therefore, I get P of 1 by 2 by 1 by 2 by 1 by 3, which is substituting, which is the 3 by 4. Therefore, this helps us to understand a relatively unfactored things. In this case, the biggest assumption was an unfair dice. Theoretically, an unfair dice does not exist, right? Practically, rather. Theoretically, it can exist. Practically, it cannot exist. But still, we are able to figure out a probability of that particular thing. Now, with this explanation, let's go ahead and read what does the Bayes theorem tells us and how that particular thing takes you a good information. Now, read this particular definition. Bayes theorem is used to revise previously calculated probabilities based on the new information. Probability can be revised when new information pertaining to a random experiment is obtained. The application of the results of probability theory involves estimating unknown probabilities and making decision on the basis of sample making decision on basis of new sample information, estimating the unknown pertaining to the random experiment. So the whole intent of Bayes theorem is to calculate the probability of an event that theoretically can exist but practically might not be a possibility, and that is one of the main reason why we use as an algorithm. All right, so we try to check various options out of it and use there is a base algorithm available as part of the machine learning exercise. We If we understand the Bayes theorem clearly, how exactly it works, what exactly shapes up, then it becomes immensely easy for us to go ahead and see clearly what, where, how to do things. So that's the whole concept in terms of understanding the Bayes theorem. So if we have to just go ahead and if you have to go ahead and check the Bayes theorem, if you see, this is what we happen to check the thing. So in summary, Bayes theorem becomes very handy instrument, and we can know the things how to make it very easy. Okay, so this was an approach for us to understand the various activities with regard to probability, statistics, and the associated areas for machine learning. So with this, we will get into a very different zone where we try to talk about something which is of higher curiosity quotient. Okay, so we will also happen to talk about in our coming sessions. Probably we will In the next 1 or 2 sessions, we will also try to talk about various Python libraries which we have for various things like EDA and the data cleaning, all of those. So let's try to see a gist of it before we get to our neural network. Okay. Okay. So that is the way you happen to go get going. So let's see the thing with regard to consuming data, right? So one of the main things which happens for consuming data is basically your data perception. So what we call a data perception, let's go ahead and see that particular thing. Okay, so yeah, basically okay, I see some of you have a question with regard to the formula. So with regard to which formula are we talking? Sridhar Raja. So are we talking about the base formula? P of A of B is equal to P of B of A into P of A by P of B. Okay, let me go to the previous slide. Okay, this formula. Oh, okay. This, okay, this I will get it corrected. Yes. P of B of A. Oh, okay, this formula I will get it corrected, but the actual formula is this. Okay. Okay, got you. Thanks for that. I did not realize. I think I had put it for some other reason. I'll get it corrected. But this is the real formula for base theorem. Okay. Now we will quickly get into the section which is very intensive, where we try to use all the facts what we do. So read this particular statement by IBM data analysis. Very interesting thing. 80% of the time a data scientist spends is simply finding, cleaning, organizing, leaving only 20% of the time to do the actual performance analysis. A very bold, interesting statement. So if you are working on any given assignment for 100 hours, what we are saying is you would have spent anywhere between 70 to 80 hours doing data cleaning alone, doing nothing, only data cleaning, which means a data cleaning is an intense task related activity. And if you say I am a perfectionist in data cleaning, then you are actually bluffing. The reason, there is no one way where you can say you can do an accurate data cleaning. A combination of multitude of approaches only allow you to do a data cleaning. A data cleaning can involve anything and everything, right? So with so many projects getting carried, we get to hear this bold statement. But what is data cleaning? We heard data cleaning is very time intensive. Then I also went ahead and said there is no one way of doing data cleaning. But what is it? Let's see that quickly. A data cleaning can include multiple things. Let's try to attempt what all we try to do in a data cleaning. Okay, so if you see the standard types for something which is missing, for example, there is a set of records. In between, there are some records which are not recorded or some data which is not available. You might have not applicable, NaN, or just blank, which means if you have multiple sources of data, one person might have put Na, one person might have put NaN, one person could have left blank, which is you have to standardize the way this is put. Like if you see non-standard types, somebody has put just hyphens, somebody have put small na, somebody have put n slash a in lower case, which is very, very non-standard. Next comes unexpected types, which is more to do with the data type. For example, if you have a field which is free text, free text is a string. A string is alphanumeric. You can enter both numbers and alphabets. Now, if you see Joe, Mary, Bob, 12, all of these are entered. What is entered? We don't know. Here, 12 is an integer, Bob is a character. So, unexpected types is one of the main point of contention when we have to cleanse the data. Summarizing the data, we have to summarize. This is basically a pandas function, so where we summarize the data to see how many values are there, how many are the total values. So if you have any missing values or find the number difference, we can see. And if you have to replace any data, we use again a pandas function. When we try to take about that library, we will do that, but that is again the pandas way of doing things. So if you see this, a very interesting straightforward data, I have taken a very simple data, only 4 columns, which says the serial number, street number, street name, number of bedrooms, own, occupied, yes or no. These are the 4 columns what we have, right? So street number, street name, number of bedrooms, own, occupied, yes or no. See how crazy the data can be. In the street number, there is one record which is totally blank. There is one record which is saying not applicable. In your number of bedrooms, you are writing NA as small, uppercase, lowercase, 2 hyphens. In one occupied, instead of logical answer yes or no, somebody has put 12. Here there is nothing, blank. This a simple, very, very, very basic example. But this is the way you have to deal with the data. Now, if you happen to see, you have to start dealing with all of this standard missing values. So what do I mean by missing values? In this case, this was a missing value, this was a missing value, right? So I had a value which is missing. I will decide whether it is important or not important, but to start with, it's a missing value, right? And if you happen to see there is an NA, clearly these both are missing values. Then talking about the space because all these particular things are about how exactly you normalize the data. Because until and unless you don't normalize the data, you will not be able to use the data the way you need. So is, null, or filling, all of this happens to be put here. So let's, if you see in the number of bedrooms column also, which is a non-standard and missing value, there is a missing value in this case, and the way they have put not applicable is non-standard. It might be 1 record, 1000 records, 1 million records, but your approach to solve the problems will still be the same. This for us is, since we only have like 10 records, we are able to see it on the screen. It is becoming visually very easy for us to say these are all the problems. Imagine I give you the data of number of orders which are created by any of the retail store on every given day. It will be few thousands per store, and we just cannot visualize the way we are seeing, which means we need to do a data treatment. Until and unless we don't realize what all needs to be treated, we will not even know what to treat, how to treat. Right? So that is the whole thing of non-standard missing values. So it can be anything which you don't even realize. Here, if you see unexpected missing values in a logical field, the answer was only two. It should be yes or no. But we see four different values. Y, N, 12, space. Probably somebody tomorrow can put their name also. Which means you are trying to deal with the data inconsistencies. So that way you happen to see all the things which are very, very evident. So when we are trying to consume the data, what we say a loop, right? When we loop through each entry of the owner occupied, we have to change the values, and then only we will be able to consume. If there are any values which are not as planned, your whole thing will get a reboot. So all these particular things, whatever we have to do, we have to normalize. So in this case we'll have to make it logical. Then if you are also using encoding, what is encoding? Anybody? What is encoding with reference to data cleansing or data analysis? Anybody wants to take a shot on the chat window? Encoding. Anybody? Okay. Encoding is an approach of converting values into something with a logic. For example, if I happen to say, let me take this example here, my number, sorry, own occupied, we know the values should be only yes or no, right? So what we are trying to say, it should be either yes or it should be either no. Now what we can do here is, if we can use a method of encoding where we can say wherever we find y, put it as 1, wherever we find the value as n, put it as 0, which means you have done a replacement approach, and then it becomes, because handling integers in programmatically is very very easy, right? So that way you can do the thing. So basically if you see in the number of bedrooms, anyway it is numbers, it should always be either probably you know, there may not be a house with 0 bedrooms. It should be a either a number 1, or it should be less than 3 or less than 4 based on what data you are collecting. So you can put some conditions here. In the street name you just cannot do multiple things, so you have to live with strings, but there your string values can be normalized. So if you see, data is serialized or converting values, as Srinivas says, it is the approach of encoding. So that way whatever data you have, first you are converting it into a consumable format, then you are consuming or converting the consumable format into a computing format, right? So the raw data, which is a raw material, will be in different shapes and forms. It has to be transformed, what we call as data transformation, and data which is transformed has to be now converted into computative data, so where we can do our computations. That particular thing is really 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 an art. You should get as creative as possible, right? It is, though it is a practice of doing things which is not very very interesting, I somehow can tell it can create lot of boredom, because you keep seeing data, a lot of data, but until and unless you don't identify, you cannot make data cleansing as an interesting activity. And we know in any activity 80% of the time is into this activity, and we, if we get lost in doing this, the 80% of the time can become 160%, which means even after your planned deadlines you might have not even completed your data curing. We also call it as data wrangling. So that is the power of data cleansing. A right approach to start with only can help us. An approach with a casual intent will always create more challenges than the easy thing. So if you see this, after we have cleaned the missing values, we probably want to summarize. For instance, we might want to look at the total number of missing values, replacing the missing values, and get the whole things into a fashion which can help us to compute the data. That gives us the whole summary. So why did we bring this here? Will be a question. We were talking about statistics, we were talking about probability. Then why we started with data cleansing? Many a times, or rather, I will say 8 out of 10 times, you will have to use your data cleansing associated with statistics. You might have to replace the values using a mean, median, mode, or you will have to see how much of value is variance. What was the planned value? What is the actual value? Where does the variance start? What is the standard deviation? These are all the statistical terms which we should know at your fingertips. Then we will be able to mold the data the way it will give meaningful insights. Otherwise, it's like searching a needle in a hay of grass, right? So basically, you have to, one is knowing all the statistical functions, the other is applying those statistical functions very, very ergonomically on the data what we consume. Okay, so this gives us that required thought process in terms of where, what, how we do the things. Okay, so saying this, let's get into the second topic which we planned for today, which is the introduction to neural network, or what we call as artificial neural network. Very, very interesting topic. Before even we get into neural network, we have discussed various things about machine learning. Now, there can be a very, very simple, straightforward question saying that when we already have a machine learning, which is an aid to solve problems, why is there any relevance of trying to talk something in something called as neural network, and how a neural network plays a role in this whole episode, right? That's the whole challenge what we get to see. Let me help you understand this question. So if you walk back 2 to 3 days back when we did the NLP, there was an interesting statement which we made about the ambiguity. We said a fisherman went to a bank. Okay, a fisherman went to a bank was a statement, and each one of us at the outset can assume whatever we need. Some of us, because we said a fisherman went to a bank, the closest relationship what you thought of was a river bank, and you said being a fisherman he has a higher chance, or the maximum chance, or the only chance to go to a river bank. But he can also go to a normal commercial financial bank. Nobody stops a fisherman going from a regular bank to deposit money, withdraw money. Now, as a human being, without your active consciousness, with reference to various other insights, you know what contextually you are talking. Assume one of you and me are talking right in front of a regular bank, saying a fisherman just went into a bank. We know what we are talking because we see a bank, which is our visual input, and we have our verbal discussion. So we are able to relate things both visually and verbally, and we are able to decide that the chances of a fisherman going into a commercial bank is much higher, while if the same discussion happens near a river bank, we know that a fisherman has gone to a river bank without explicitly mentioning a river bank or an actual commercial bank. But but how can we expect machines to take such things when there is a overlapping of data? Which means, how do you make machines understand contextually? That's where the gap comes with reference to solving your problems with machine learning. So, as a thumb rule, as a rule of thumb, you can always assume that whenever the data is more structured, rows, columns, you can use your machine learning, which means there is a well defined data like what we saw here, right? In the housing data, what we saw here, it's a structured data. You have rows 1 2 3 4, whatever the rows, you have columns 1 2 3 4 columns. That when it is very very distinctively differentiating, machine learning can consume, analyze, visualize, influence the decision. But whenever the data is unstructured, overlapping, machine learning ceases to give that information, and that is when we will happen to use something called an advanced technique which involves neural network. So what we will do is we will take a quick bio break, come back, start with the understanding of artificial neural network. Very interesting thing where we try to connect biology and uh, machine learning with statistics. So we will get there and see how it can happen. Okay, let's take a quick bio break and come back.
स्टार्ट वीडियो फेस दिखेगा तेरा कितने जाएगा तो बताएंगे कितने लोग जाएंगे मेरा बंद है कि नहीं देखा अच्छा है मेरा मॉड्यूल चालू है
Okay, are we back? So I think we have all of them. Let's get started understanding the artificial neural network. Okay, so why a neural network? The first and foremost question, right? So why a neural network is very, very interesting. So if you happen to see the problem before neural networks in a programming, look back and see what you can do. In a programming, you try to put various conditions, try to address only those conditions, or you happen to execute an exception and return rather than making any runtime decision. Which means, for example, how does your simple if conditions or loops work? They all work on a predefined boundary. And the only way you can handle those exception is basically you say either terminate the whole process or try to say I don't know or I need further information and you get back. But a human way of doing things is slightly different. When I say slightly different, if I give you this example of what we called learning, we try to use the quotient of learning to make some runtime decisions. It could be as simple examples like we said, crossing a road. You never learn to cross a road which you are going to cross tomorrow. The road which you are going to cross tomorrow is based on your learning what you have done today or yesterday, right? Similarly, climbing up the stairs. Every staircase is different, but you still climb up the stairs with no problem. But making a machine try to do that using a conventional approaches fails drastically, right? So if you happen to see that the computer follows a set of instructions in order to solve a problem, which means if there is a gap in the instruction, the computer fails to solve a problem. But the biggest advantage of a computer is if you have a right instruction, it can do things meticulously correct, right? So that gap what we have today, we try to fill that using the neural network. Let's see that particular thing. What is a neural network? A complex network which has a high density of computational power. You might be surprised. You might be surprised if I tell you a very simple thing. Think back in your life, have you ever measured the height and width of the stairs what you are going to climb? It could be a staircase in your house, it could be in a mall, it could be in a theater, it could be in your college. Ever have you measured what is the height of the stairs what you are going to climb, having a measuring tape for climbing? Probably never. But do you think without knowing the height of the stairs, will you be able to climb up? The answer is no for both. You never carried a measuring tape to say this steps are 6.5 inches of height and there are 14 steps. So I need to lift my right leg 14 times by 6.5 inches, left leg by 8.5 inches, then only I will climb. You never do that calculation. But still you are able to climb up. How does that work? Because there is a passive calculation happening in your neural network which is sending in the results, and that is how the coordinated effort of your right leg and left leg is happening before you climb up. Your eyes are passively sending the information to the brain. The brain is passively calculating the height and pushing the information required to your legs, and the legs are moving. The same thing happens when you're crossing the road. Have you ever calculated what is the speed of a vehicle which is coming on your right hand side, and you say, I have to walk 14 feet. The car on the right side is coming at 63 kilometers an hour. So for me, I require 1.1 minute. Have you ever done? Never. But still, you are able to cross the road very accurately. How does that all happen? That all happens because of your neural network, which is supporting you with that passive calculation. So whenever you don't have to specifically program, but still you can consume the data real time, compute the data real time, analyze, visualize, and decide the data real time, we leverage the help of neural network. So this is a very simple high level representation of neural network. The This is the input layer, what we call as an input layer. These are your hidden layers. We will talk about it in detail. This is the output layer, right? If this works this way, what is the motivation when we call neural network? The human being itself is the motivation, the human neuron. So that's where I said we try to bring in a very, very interesting blend of biology, data, programming in neural networks. Why biology? Because we take our artificial neural network from the biological neuron which is available in human brain. If I have to ask anybody a simple question, how many neurons does a human brain carry? Any answers? You can put it on the chat window. Anybody knows how many neurons a human brain carries? By your biological general quotient. Okay, infinite is what I get, one answer. Okay, yes, the answer is a humongous number, few millions to billions of neurons. In spite of so many neurons, we still get a brain freeze. What is a brain freeze? Whenever we have multiple inputs trying to feed our brain in one go, our brain stops responding. It's like this: try to switch on your TV, your radio, your phone, start talking to somebody, try to do all of this in one go. You'll not be able to decide what to do. That's the state of brain freeze. In spite of having a multiple neurons, which means the decision capabilities will cease to get over. So, with that in background, this is a microscopic view of one of the neurons. So I keep seeing interesting numbers: 2 trillion or 100 billion neurons. A huge number. Actually, you just cannot count, right? So that big number, and this is one of such neuron what we are seeing. A very high resolution, very high, basically you have seen under a good magnification to see this. The tips, or what you call the tail, is called as a dendrite, receives the signal from other neurons. So basically if you have to compare, this is the connecting layer between one neuron to the other neuron. The second one, or the second stage, is your cell body. What is a cell body? It sums all inputs. If you see, this neuron has multiple dendrites, not a single dendrite but multiple dendrites, which means there should be a mechanism which sums up all the inputs what it gets. And then comes your axon, which is used to transmit the signals to the other cell. Therefore, input is received at dendrite, summation happens at cell body, axon transforms or transmits the data, the transformation happens at the cell body, transmission happens at the axon. The tip of the axon is called synaphase. This is the biological naming of a simple neuron. And just for all our information, the best of the best doctors in the world, neurosurgeons, neurologists, or the scientists, whoever we claim, they also claim they only know 5 to 8% about the working of the brain, which means We hardly know less than 10% how a human brain works. And whatever that less than 10%, 5 to 8% we know, we are trying to replicate. Now you can think how much of gap we have in analyzing and understanding the brain. That way we can leverage the whole learning cycle, right? So this was the biggest motivation behind the neural networks, or what we call as artificial neural network. Now what we do here is we do an apple to apple build, right, to get our artificial neural network. So where our artificial neural network actually brings very very helping hand is in this image. If you see, this is a family photo of a couple, two children with a dog. Now how are you able to identify? It's a computer vision and a human vision. I am displaying on a computer which is having a computer vision. Now you are able to see this: a couple, a father, a mother, two kids with a dog. Now if you have a machine learning algorithm, you have a machine learning algorithm where you have trained this machine with various kinds of dogs, and fortunately, unfortunately, in your training, this kind of dog was not at all part of your training. And I can tell you, most of us might be seeing this kind of dog probably for the first or the second time. But still, you were able to identify it as a dog without any much effort. It could have been any pet, right? It could have been a cat, it could have been a fox, but you were able to say this as a dog, while a simple machine learning algorithm fails identifying this because its training was not on a dog which is available here, right? So to that thing, the answer is you leverage an extensible approach, what we call as artificial neural network. And many a times I just compare this to an approach of maybe, because many of our decisions might not be logical, but they are between zeros and ones, and that's where our intelligence comes into place when we have to identify something. Now you might have a question of ambiguity, or saying what kind of a pet can be this, or I see this, there are some ears which are large, long, so probably they have a higher inclination towards a dog rather than a cat, and that's how you probably will conclude that this is a dog and not a cat. We try to leverage the same thing in our neural network. Let's see that how exactly it works. This, though, seems to be a very 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 complex or a heavyweight image. Let's try to understand to make things relatively easy. So we know the left side first, the biological neuron. We said dendrite. This is the cell body, this is the axon, this is the synapse. All of this we identified. So using this as a baseline, we build something called as an artificial neuron. An artificial neuron is also called as perceptron. So a perceptron is something like this. It has various placeholders for input. X1, X2, X3, Xn are all your placeholders for your inputs. W1, W2, Wn are all your placeholders for your weights. Now you have something where we happen to process the data, processing element, which is the summation where we did in the stem of the body. Here we do the summation. Then we have something called as the transfer function, where we fire the outputs. Now, what is firing of the output? Right? In this picture, the moment you saw a dog, or the moment you saw this picture, somewhere in your brain, you were able to identify quickly saying this is a male, this is a female, a girl child, a boy child, and a dog. Which means you were able to compare few attributes from the image and you got your answer tickled into your brain, identifying this as a male, female, a boy child, a girl child, and a dog, which is a point of firing your output. That is what we do here in the transfer function, which means we fire the output y1, y2, y3, yn based on the number of inputs. So if you happen to see your right side and your left side, we are trying to build what is in the human biological neuron. Artificially we are trying to build that, where we have the placeholders to take an input, placeholders to do the summation, placeholder to transfer the data and get the output. So that's the whole logic in building a neural network artificially, or commonly called as artificial neural network. If this is the thing, what happens, like any machine learning algorithm, like any other machine learning algorithm, the neural network also has two phases: a training phase, a using phase. What happens in a training phase, the neuron can be trained to fire for a particular input of parameters. In that image, or in this image, probably if I happen to ask who is a person who is teaching here, you are confidently able to say it's a male who is teaching there. And the answer is obvious. You see certain attributes in this image, a person with a suit with a tie. So you are able to go ahead and identify this being a male. But if I ask, is this a male or a female, probably you might have to think few minutes before you categorize whether this photo in this slide is a male or a female, unlike this, which means your firing of neuron for the output is not getting processed immediately, because there are, in this case, there is no very evident attribute which can tell you is this a male or is this a female, right? Probably seeing the dressing attire, you have an higher inclination saying it might be a female. But evidently, like here, a person with a suit, with a tie, some attributes which fires your output based on certain input parameters is not happening here, right? So this is your training, this is your using. So in the using mode, when you taught an input pattern is detected as input, its associated output becomes the current output. So if you happen to go ahead and look at any training things, probably you never are trained saying that these are all the facts which will have to be considered to categorize a person as a male or a female. But over a period of time, you get trained in such a way saying that these are some distinctive features which you should look for before categorizing a person as a male or a female. The same thing happens here in your training and using mode, right? That is the way it can make things really, really interesting. Now, if you happen to see, there is something called as activation function. So an output is derived based on activation. So there are multiple activation functions which are available in neural network. Some of the evident ones are a step function, sine function, and a sigmoid function. A step function is between 0 and 1. A sine function is between -1 to +1. A sigmoid function is also between 0 and 1, but an S-shaped function. So these are the various activation functions. So anybody who already have seen some of the neural networks algorithms, you have a ReLU activation, sigmoid activation, step activation, sine activation. These are all that activation functions which we leverage on the neural network before they can influence an output. So if this is your activation function, then let's see a perceptron training with an analogy. A very, very simple analogy I will explain. You will be able to understand how the training works. Okay. Now, let's take this simple analogy. Assume there is a beer festival near your house. Okay, there is a beer festival happening near your house and you wanted to go to the beer festival. Now there are three main factors which will help you to decide whether to go to the beer festival or whether not go to the beer festival. What is that factors? Let's see. You are very keen about how is the weather. Weather plays a role for you to decide whether you want to go or not go. Second, is your spouse accompanying? For people who are already married, this is one other fact which can help them influence whether they have to go or not go. If their spouse is accompanying or not accompanying, they have a pointer to decide. The third pointer is any public transport which is available. Public transport is available, then you have a fact to go, or if it is not available, you have a fact not to go. Now, with these three things, let's see what a neural network will act as. So, if you see the three inputs, I put it as a picture. The first input, the weather. The second input, the spouse accompanying. The third picture of public transport availability. Every question has two answers, 1 and 0, right? For example, for the weather, which will become your first input, which is your x1. If the weather is good, your answer is 1. If the weather is bad, your answer is 0. Similarly for x2, if she if the wife is accompanying, or if the spouse is accompanying, the answer is yes, which is 1. If the answer is no, it is 0. Similarly, if the public transport is available, the answer is 1. If public transport is not available, then the answer is 0. So, for every input x1, x2, x3, you have a valid output. Alright. So, that's the way you have the things. Now, if you see this particular thing, and we go further, a combination of the three questions, if it yields 0, you sit back at home, enjoy the TV. You are not going to the beer festival. If the output is 1, you plan to go and enjoy the beer festival. How does this actual calculation work? Let's see this. Which means, suppose for you the most important factor is weather. Imagine there are three questions, right? Weather, spouse accompanying, and transportation availability, public transportation availability. You are trying to see which input is of higher importance. Which means, suppose for you the most important factor is weather. If it is not good, you will definitely don't go, even if the other two inputs are high. If it is good, then definitely you will go, which means the weather factor has a relatively higher importance as compared to your other facts. That is what x1 is equal to 1, output will become 1, which means you will go. If x1 is 0, output will become 0, you will not go, which means let's see how the mechanism of weights will work. Now, see this. You had your inputs as x1, x2, x3. For each of the inputs, you have a weights W1, W2, W3. That are your weights. Now, for a purpose of calculation, let's assume our weights are like this. Our weather is very important. W1 is equal to 6. Spouse accompanying weight is 2. Public transport weight is 2. Now, if you happen to calculate with this weights, W1 is equal to 6 and the weather is good. Therefore, 1 into 6. The weight for your spouse accompanying is 2 and your wife says she is not accompanying. Therefore, 0 into 2 is 0. Public transport is not available. 0 into 2 is 0. Therefore, 1 into 6 is 6 plus 0 plus 0. The output of this calculation becomes 6. And your threshold value was 5, which means the sum of this computation, if it is greater than the threshold, your answer is yes. If the sum of this value is less than threshold, the answer is 0. So in this case, if you change the output, so for example, your spouse is not accompanying, sorry, your weather is bad, which means 0. 0 into 6 is 0. Assume the spouse is accompanying, therefore 1 into 2 is 2, and even public transport is available, 1 into 2 is 2, therefore 2 plus 2 is equal to 4. If this is the threshold, sorry, if this is the output and threshold is 5, 4 greater than 5 is false, therefore you will not go. Why? If the threshold has changed to 3, 4 is greater than 3, therefore you will go. Which means with 3 inputs, you have various permutation combination. It could be 0 into 6, 0 into 2, 0 into 2, 1 into 6, 1 into 2, 1 into 2. All permutation combinations are valid, but when the inputs and when the weights change, your calculations, all of them change. So for a person, for one person, the weather might be important, for another person the public transport availability might be important, or for the other person's spouse accompanying might be very important, which means accordingly the weights change. When the weights change, your calculation also changes, and accordingly your neurons will either fire 0 or 1. That is your way of doing things and happening to make the whole purpose. Right? So this threshold, there is no single approach saying what is the threshold, but we try to go ahead and calculate iteratively. That is why a neural network is very calculation intensive. A machine learning is less calculation intensive, while a neural network is very highly calculative intensive. That's why I said your brain, which has a neural network, is doing it for you, and we are not realizing the power of the brain. Because this is a natural phenomenon for you. If I happen to say you go to a buffet and you want to eat, probably you will not eat all the 40 to 50 items which are available in a buffet. You go through a decision process and decide what to be put on the plate, and then a second layer of decision, whatever you have in your plate, what to eat, what not to eat. Which means you know how much of inputs, how much of weights, how much of dynamic change in weights and inputs is happening before a piece of food goes into your mouth. All right, plate to fork. All right, so that is the power of neural network. This way you get very interesting in terms of doing the calculation and getting your whole intent of getting the result. So this was a simple gist of how a simple one neuron works. But if you happen to see the same thing in an actual functioning, this is the multi-layer perceptron. Now, a very evident way of looking things, where this was your x1, x2, x3, all your inputs. This is your hidden layer, and if you see, this is a fully connected neural network, which means every neuron in your input is connected to all the neurons in the second layer, and all the neurons in the second layer are connected to all the neurons in the third layer, and all the neurons in the third layer are connected to all the neurons which are available in the fourth layer, which is the output layer. So this is the input layer, this both are your hidden layer, this is the final output layer. And if you have to see this pictorially, a very good example, probably now if you go ahead and see your primary school group photo and try to identify one of your friend from that photo, how do you go ahead and identify? First, you have an input saying whether the friend you are trying to look in the group photo is a male or a female, which means the patterns of local contrast is happening. Because this is a group photo, lot of people are available in a group photo. You are trying to compare the patterns of local contrast. And then in this group photo, there can be multiple objects. You go ahead and see which are all the faces. Then on that faces, you try to identify whether you are looking for a male, female, which is the actual face. There might be multiple people within which you choose, and you say, yes, this is the friend, he or she whom I was looking out for. And that's how you figure out, saying that this is a person whom I was looking. That way you happen to do your uh, approach of finding a person, and this is what happens in a real artificial neural network. The input layer slowly gets computed, and if you see, this is all of this is completely connected layer. Every neuron here is connected to this, this is connected to this, this is connected to this is connected to this, which means the fully connected approach of computation is happening. And that's where you get to understand the objects within a photo. So with this, what we get to see is a understanding of artificial neural network. So with this, we will conclude our session today. Any questions? Because we have to continue this, I will take the example of how we train the neural network tomorrow. We will take a working example where we feed the data, try to understand the various concepts, see how exactly the neural network works. All of this we will do it tomorrow. But if you have any questions, feel free. And I think Dilip or somebody will go ahead and upload all the documents today and tomorrow. You should have access to all of them. And if you see anything missing, please tell, he will upload all of them. Okay. So like I said, threshold is, there is a calculation which I will explain when I take the algorithm and show it. But a comparison of output and threshold, it plays a vital role in our artificial neural network. There is, you don't have to find a threshold value, you have to feed the threshold value. Now it is like this: when you have 6 starters in a buffet, all are looking very yummy. If I ask you a question, why did you choose one starter between the 6? What is your answer? All are equally good, all are equally stimulating, the good appearance, good color, good aroma. But you cannot eat all the 6, which means you have chosen only one. Tell me, what is the reason for that? Each one of you have a different answer, right? Probably some of you go by the appearance, some of you go by the ingredients, some of you go by the aroma, some of you go by the experimentation, which is the point of threshold. Similarly, when I have to take a machine, I will have to influence the threshold and get the value. So that's why I said, when I pick the program, I will show you the working model of threshold. But theoretically, understand this is how it works. Okay, got you guys. Any other question? Okay. With this, we will stop our session today. Thanks, everyone. Have a good day. We will catch up tomorrow. Thank you. Bye.